morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is comparison between the 3 and 2 hinged arches. Here, in previous lecture, what we understand, according to the arches, as per the arches, so it is the one of the concept which we are understanding under the analysis of structure. In arches, it is available in various categories. So we may adopt as per the practical scenario and what are the conditions are there, which one gives the best results. According to that, we are going to choose the which type of arch is suitable for the conditions. As per the conditions, we are going to adopt the which type of arch is suitable. So these classifications are categorized as per the different parameters based on their own different characteristics. Those are based on geometric, based on the size, based on the shape, based on the number of hinges, based on the material which we provide for the construction work, what type of material we are choose for construction of that particular arch. So these are all the various parameters which are involved for categorizing the arch. In that, according to the hinges, number of hinges are there in that particular arch, we are going to classify the arches in 2 ways. Those are 3 hinged arches. In these, we have 3 hinges are placed at different places. 2 are at the end of the arches, end supports. One is on one end and the other one is other end. And at crown, one more hinge is provided. Such types of arches are known as 3 hinged arches. And also, move on to the 2 hinged arches. What kind of only 2 type of hinges are there at ends supports. Such type of arches are known as 2 hinged arches. So in that the difference, they may be symmetrical, they may be unsymmetrical, and there may be different types of loadings are involved, loading scenarios are involved. So we are understand all these things, how we are analyzing based on the vertical reactions, how we are find out those vertical reactions as well as the horizontal reactions at any point of the particular arch, their movements. These are all parameters we observe and we understand as per our previous lectures. So based on the numerical ones. So in some of them may symmetrical, in some of the situations they are unsymmetrical, and depends upon the loading condition also. So point loads, concentrated loads, various loads are involved in that particular single arch, uniformly distributed arch, one side uniformly distributed arch, another side different point loads are there. These are all various conditions are there for analyzing the arches. For those different scenarios, we have few, so we understand some examples. According to that, in any kind of various arches which are involved in that, various kinds of characteristics like normal thrust, radial shear stresses, internal stresses, shear forces, bending movements, these are all are involved in any kind of arch, whether it is 3 hinged arches, whether it is 2 hinged arches. We are going to analyze all these parameters in our previous lectures. So in those, we understand the internal stresses and how they react for various load conditions. We will observe and we find out all unknowns using various conditions and using various equations. In some of the situations, those equilibrium equations are more than enough. And in some more situations like arches, so we need some more additional compactability equations for know about the unknowns, like various forces which are reactions which are involved in that particular arch. So like now in this particular lecture, we are understanding the differences, how we are going to compare these 2 arches based on the hinges we are categorized. So how they are, we are going to realize, and what are the various parameters involved, what are the various analysis, the way of analysis, how we describe, is there any similarities, how we differentiate these two, we will see in this particular lecture. So these are the some of the course outcomes already we see in our previous lecture. Now compare to between these two, we may consider in structural characteristic point of view. So in structural character point of view, we have to understand the first parameter. The name itself tells us that is 3 hinged and 2 hinged. Here, the first parameter, that is whenever 3 hinges are there, whether it is symmetrical, either symmetrical or non-symmetrical, this is the hinges, these are the hinges which are there for 3 hinged arches. 2 are at end supports, other one is at the crown. This is nothing but the crown, highest point of the arch. So here, whenever the additional is labeled, it is there. This is A, B, C, and this is also A, B, C. Whether they are symmetrical or unsymmetrical, these 3 hinges are identified as 3 hinged arches. And here, one more, in this, whenever the hinged crown allows the arch to rotate slightly, which can accommodate the changes shape due to the external forces or deformation. For example, because of these kind of 3 hinged arches, here also there. So this A, B, C. Because of this third hinge, it is allows to rotate slightly. It allows the rotation, which can accommodate changes in their shape. So as per that, it allows the, due to the external forces, whether load, point loads, concentrated load or uniformly distributed load, so our entire parabolic arch may under these load. Otherwise, sometimes the uniformly distributed load is confined to half portion or somewhere else, some distance only. Such type of scenarios also we may observe. So this is the overall span length, that is L, only L by 4 distance from crown to right hand side of the arch. This uniformly distributed load may act. So according to all these changes, we are going to understand in these 3 hinged arches, it allows that slightly rotation. So this is the one of the structural characteristics. Some of the structural characteristics we may understand in these hinges, and in the especially for these 3 hinged arches in statically determinate. So this arch type, this 3 hinged arch type, 3 hinges are statically determined, because for knowing about these internal forces or reactions, those are shear force, axial force, moments, and any other internal forces at any point, we are going to determine using the statically determinate equation. Those are 3. Those static equilibrium equations is nothing but the sum of the horizontal forces involved in that particular given arch, irrespective of the shape and sizes of the arch. In 3 hinged arches, the sum of all horizontal forces is equal to 0, and also the sum of the all vertical forces is equal to 0, and the sum of the moments as per the load conditions. We may have n different type of variety of loads may involve in that particular 3 hinged arch. Even though the sum of all movements should be 0, these statical equilibrium conditions are enough for understanding and for analyzing the 3 hinged arch. Using these 3 equations is enough for getting these unknowns, like these unknowns. Reactions also, internal reactions also. This statically determinate structure is enough. Such type of arch is this 3 hinged arch. It belongs to statically determinate. and there are no redundant supports or unknowns, so it is easy to analyze. If may know the things within these static equilibrium equations, these three equations are enough for getting the whatever the unknowns involved in that particular structure. It is easy to analyze. So that's why there is no redundant supports or unknowns, such type of statically determinate structure. So for analyzing, it is the easy one compared to the two-hinged arch. What is there in two-hinged arch in structural characteristic point of view we will see, and later we will discuss about these comparisons. So, and one more is the flexibility. So here the presence of three-hinged crown provides flexibility along this structure to adjust the settlements of the supports or thermal expansions or contraction. So any kind of structures, these thermal expansions and contractions are depends upon the type of material, how much they are going to expand or how much they are going to contract based on the temperature changes of that particular locality. Depend upon the temperature changes. So in this type of, it depends upon the material. Once they are going to affect, the effect is more when compared to the other type of materials which we are providing, or the thermal expansions are there. But this three-hinged arch, whenever the hinge at a crown point, that provides the flexibility. So that provides flexibility because, and also it allows the structures to adjust to the settlements what are happening because of these temperature effects. Those are thermal expansions or contraction because of the temperature effects. Because of the temperature effects, it is going to adjust to settle because of the three-hinged. The third one more hinge which is there. So that one is helpful for this flexibility. And also because of this flexibility, it reduces the risk of developing significant internal stresses due to the unexpected deformation. Because of these temperature changes, we may get any kind of stresses, internal stresses or unexpected deformations. So it reduces the risk and also for developing of the significant internal stresses due to the unexpected deformation. So whenever the crown have that hinge, so these are the advantages we are going to understand. So these are the adjustments we are going to understand in this particular condition. So in these internal forces, what are the internal forces which are involved in this? Due to its flexibility, a three-hinged arch typically experiences the lower internal forces when compared to the more rigid structures. So whenever we compare these type of scenarios, these internal forces, because of these flexibility, characteristics of this flexibility, in three-hinged arches, they are typically experiences the lower internal forces when compared to the more rigid structures. So the moment at the crown is always zero, which simplifies the analysis and reduces the bending stresses. So without that, it may increases the risk of the bending stresses because here also one support is there. So it reduces the bending stresses. Bending stresses are going to reduce. Bending stresses are reduced. So these are some of the structural characteristics which we are going to understand in these three-hinged arches. Move on to the two-hinged arches. Here, it may be symmetrical or unsymmetrical. It depends upon the scenario of the practical application where we are going to apply this two-hinged arch. So using material also plays a role. What kind of material we are using for this two-hinged or three-hinged arches also we are going to compare because of the stresses and thermal expansion and contractions. some more internal stresses, how they are reacted, based on the internal stresses were developed. So these are also involved in these things. So here they are maybe symmetrical, A and B are in the same line, other they are maybe unsymmetrical in this way or this way. So it is depend upon the scenario of the where we are applying these kind of conditions. Two hinged arches. There is no such type of hinge at any crown. So from here to here, this is the crown. There is no hinge here. Simply it is a arch. We are providing with two supports. This is symmetrical condition. These are two different unsymmetrical scenarios. Here, the two hinged arch has hinges only at supports. Those are point A and point B. There is no hinge at the crown. These hinges allow for rotation but resist horizontal and vertical movements, because there is no such type of here it is there. In three hinged arches we have crown, also have the hinge, so it resists that rotation. But here in two hinges arches allow for rotation but resist horizontal and vertical movements. And in this two hinged arch, it is statically indeterminate. See, so in this two hinged arch is statically indeterminate to the first degree. This means that the structure has one more unknown that can be determined using the three hinged equilibrium equations alone. And it may not be an additional equation usually derived from the deformation of this structure, such as compactability conditions, is required to be fully solve the structure. For two hinged arches, this is statically indeterminate structure. Statically indeterminate structure. It comes under statically indeterminate structure. Those statical equilibrium equations are not enough. Statically equilibrium equations are not enough for understanding, for getting the results, for finding unknowns. Those are nothing but, what are those unknowns? Those are nothing but reactions and movements. Those reactions are nothing but shear forces, bending moments and axial forces. So those are not enough for getting the unknowns present in these two hinged arches. So here we need additional conditions required. Additional conditions for getting the unknowns. Those are reactions and the forces. So according to this type of structure belongs to statically indeterminate. So this f of x is equal to 0, f of y is equal to 0, sigma m is equal to 0 is not enough. It required additional conditions, additional equations for know about the unknowns in this particular statically indeterminate structure. That for example, that is two hinged arch is a statically indeterminate structure. So and one more we are going to understand the structural characteristics is flexibility. Lacks the flexibility of three hinged arch because it does not have a hinge at the crown. So it lacks the flexibility. In three hinged arch, it is flexible because of it has hinge at crown. And this makes it less accommodated to support settlements or temperature changes. It is going to settle and temperature changes also. These thermal expansions or contraction because of the thermal conditions. It is going to affect these two hinged arches because of the only we have two hinges at the support, not at crown. And however, it does provide some flexibility, even though it provides some flexibility, not like the three-hinged arch. However, it does provide some flexibility due to the hinges at support, which can allow for rotation under loading. It depends upon the what kind of loading it is there in these two-hinged arches. Whether it is maybe point load, concentrated load, uniformly distributed load, uniformly varying load, or other only one side the loads are acting, other side there is no such type of conditions. These are the various scenarios we are going to understand. It depends upon the under loading. They are going to allow these kind of rotations based on these and supports which we are provided for these two-hinged arches also. And internal forces. One more statical characteristics are that is internal forces. So the absence of crown hinge means the two-hinged arches generally experience higher internal forces, especially bending moments. So these increased forces require more robust construction to resist potential structures. So it requires the more robust construction to resist these potential stresses. So these are the three different characteristics. Those are hinges. And according to the number of hinges, these are the structural characteristics we may observe in these both two-hinged and three-hinged arches, and whether it is belongs to statically determinate or statically determinate or statically indeterminate. Statically indeterminate. Flexibility. Internal forces. These are the structural characteristics which are involved in these two and three-hinged arches. When we are compared in terms of these four parameters, in two-hinged arches, two hinges are there, three hinges are there, three-hinged arches is statically determined, two-hinged arches intermediate. This is flexibility is more because of the crown is present, that the crown also have the hinge, and also flexibility is there in two-hinged arches also. It depends upon the supports based on the external loads. The deformation is also allows, and it requires more potential resist constructions are required because of the increased forces are there. In the absence of the crown hinge means to because it experiences the high internal stresses when compared to the other one. So these are the structural characteristics we observe comparison between these two and three-hinged arches. Coming to the analysis of complexity. In this analysis of complexity, because of in three-hinged arches, this ease of analysis, it is inside of ease of analysis because it is statically determinate. The analysis of three-hinged arch is straightforward. No additional equations are required. No additional equations. And also all unknowns, those are reactions. Reactions are nothing but axial force, shear force, bending moment. These are the reactions. Bending moments are bending moments. These are the reactions, and internal forces can determine directly using these statically equilibrium equations without needing any additional considerations or compactability equation. These additional equations are nothing but we call them as compactability conditions or equations. This is one of the ease of analysis we know. In these equations already we know, then these equations are enough. Those are the equation is used to determine the horizontal reactions. For finding the horizontal reactions, we are using this sum of the horizontal forces is equal to 0 and sum of the vertical forces is equal to 0. We are using this kind of equation. Summing all the moments in this particular we help for this all for the unknown forces. For vertical reactions, horizontal reactions and movements, we are using these equations are enough for getting the unknowns for 3 hinged arches because of the, and so that's why it is easy to analyze. So ease of analysis is there when compared to the 2 hinged arches. We will see what is there in this analysis of the analysis complexity is not there. It is easy to analyze because it's directly we are getting the unknowns using the direct equations. Those are statical equilibrium equation. In 2 hinged arches, the ease of analysis is more complex to analyze due to its static indeterminacy. Because the statical equilibrium equations are not enough for finding the unknowns which are present in these 2 hinged arches. Static equilibrium equations. For getting unknowns, we require statically equilibrium equations plus compactability equation. It required additional. So that's why for analyzing these is more complex when compared to 3 hinged arches. 3 hinged arches are easy to analyze. Coming to 2 hinged arches, it's more complex to analyze due to its statical indeterminacy. So the analysis requires not only the static equilibrium equations but also compactability condition that account for the deformation of the structure. And besides the equilibrium equations, an additional equation often derived from the how we are getting these structural other additional equations we may derive from the geometric or structural compactabilities need to solve this indeterminate structure. For example, we used a common method to use, that is deflection compactability condition. So this is generally we are using, that is deflection compactability condition. Here, where the horizontal displacement at both supports must be equal, leading to an extra equation that helps solve for the unknown horizontal reaction. And also, like this we are going to understand in structural characteristic point of view, we have different parameters for understanding the comparison between 2 and 3 hinged arches. In analysis point of view, because of the straightforwardness of the 3 hinged arches is easy to analyze when compared to the 2 hinged arches is little hard. In response to external factors, so one more parameter, that is how the 3 hinged and 2 hinged arches are response to external factors. Here, in this, the first parameter, that is settlement. So because of the presence of the hinged crowns, make the 3 hinged arches more tolerant of differential settlements at the support. Because of the thermal stresses or thermal contractions and expansions, because of the temperature effects, because of the flexibility of the 3 hinged arch. So it is going to rotate, allows to that rotate because of the flexibility. So how we will get this flexibility? And so for the additional hinge is there at crown that gives all these tolerances, and because of this we are going to tolerate the settlements at the supports. So this is the presence of the hinged crown. So this is one of the advantage, because we are getting the less settlements, even though the more deformations or unexpected deformations we may get in these 3 hinged arches, because of the presence of the hinged crown gives the more tolerant of the differential settlements at the support. If one support settles more than the other, the arch can adjust because of the rotating flexibility is there at the crown hinge. So it reducing the development of the high internal stresses. It reduces the high internal stresses. So that's why the different settlements may occur because of the different loading conditions. So throughout the span, we may not expect the same kind of loading conditions. So that is the one of the reason for having the different types of settlements in two supports. One is settlement more than the other. So that may happen because of the loading conditions. It may be one of the factors. And also the material what we used and how the temperature affects for the used material for construction of that particular arch. These are the parameters we are going to understand. And the presence of this flexibility because of the hinged crown, it reducing the development of high internal stresses. It finally leads to reduces the, it is allow the settlements and its sustainability, the equality, the equilibrium is maintained, and it is ready to sustain at particular point, at particular situations like unexpected deformations scenarios also. And temperature effects. So the flexibility of the three-hinged arches also makes it better at handling thermal expansion and contraction. The hinge at crown allow the arch to expand or contract without significant stress build-out. So without unknown, we are not considered at the time of analysis, at the time of the design of arch, even though without significant stress build-up, which is crucial for structures exposed to varying the temperatures. So these settlements and temperature effects are less risk effects because of the hinged crown is there. So that's why whenever the two supports are unevenly settled also, it is ready to equilibrium and it is ready to resist the structure arch, three-hinged arch, because of the third hinge at the crown. The load redistribution. So the third hinge provides a natural point of rotation allowing the arch to redistribute the loads more easily. This helps in maintaining the structural integrity under varying loading conditions such as moving loads or changes in load distribution also. So because of the parameter, we are going to understand all these things. It is maintaining the structural integrity under varying loading conditions also. And in two hinged arches, it less tolerant to differential settlements due to the absence of the hinged crown. So if the support settle differently, significant internal stresses can develop, potentially leading to the structural damage or failure may cause. Because of the only two supports are there, at ends only these supports are present. So because of these, so the flexibility is very less, and so the allowment of this rotation may cause in different damages to the lead to the potential stresses. It adopts these high stresses. It cannot resist these high stresses. So it adopts these high stresses. So that's why because of it leading to this potential structural damage or failure in the settlement. And in temperature effects, it is more sensitive to temperature changes, as the lack of the crown hinge means that the thermal expansions or contraction can induce additional stresses in the arch. So these stresses need to be carefully considered in the design to prevent structural issues. And also the load distribution. The two hinged arch lacks the additional degree of freedom provided by the third hinge, so making it less capable of redistributing loads efficiently when compared to the three-hinged arches. When we are going to compare with the three-hinged arches, so it is less redistributing load capacity. This can lead to the higher localized stresses, particularly under non-uniform loading conditions. In this, where we are applying these conditions, these three-hinged arches typically commonly used in scenarios where the structure may experience significant movements or deformations such as bridge designs, large span roofs, and temporary structures. The ease of analysis and flexibility make it popular choice of these applications because of the analysis is easy and flexibility is there. So because of this is popular to choose these applications, these three-hinged arches. And advantages, what we understand till now, this based on this lecture, It is easy and quicker to design and analyze due to its statically determinate nature. Adaptability to movements and temperature changes, which makes it suitable for environments with variable conditions. Typically requires less material and labor in construction, leading to potential cost savings. These are the advantages we may observe from three-hinged arches. From three-hinged arches, the analysis is easy and it is flexible. It is ready to unexpected deformations from settlement. It is going to settle even though the unexpected deformations are there. And the adaptability of the movements because of the thermal expressions and contractions. And also it requires less material and labor in construction. And also it saves the potential cost savings. In two-hinged arches, so used in more permanent structures where stability and rigidity are crucial, such as bridges. You have to remember that stability and rigidity are crucial, such as in bridges, arc dams and buildings with long spans. We may choose these type of two-hinged arches. So the increased stiffness provided by the absence of the crown hinge is beneficial in this application because it increased stiffness we are going to provide. So thus increased stiffness is, if presents the crown hinge, it's not beneficial in this increased stiffness point of view. That's why it is have this own advantage of these two-hinged arches. So here offers greatest stiffness and resistance to deform compared to the three-hinged arches. In stiffness point of view, it is more advantage because of this. There is no additional crown. The absence of the crown at hinge. Sorry, crown is there, but crown at hinge, there is no hinge at crown, that offers this greater stiffness and resistance to the deformation when compared to the three-hinged arch. In this, ideal for solutions where the supports are stable and unlikely to settle or where temperature variations are minimal. So because of these, ideal for situations, these supports are stable. They can be designed to carry higher loads due to the increased internal forces, making it suitable for heavy duty applications. These are the advantages which we are going to understand in our two-hinged arches. And overall summary of this lecture is, in three-hinged arches, the strengths are there. It is simple analysis because we may understand we are getting the unknowns by using statical equilibrium equation. Flexible because of the crown at hinge is there, so that gives flexibility. Because of these reason only, adaptability to settlements and also temperature changes, it is going to withstand. Generally more economical, the less cost because of the we are using less material and less labor is required. So it is to potential cost lead. So that's why it is more economical for certain applications. In moving to the weaknesses, less stiff. It is less stiffness. It is less stiff because of the presence of the crown at hinge. Because of the presence of the crown at hinge, we are having the advantage, that is flexibility, adaptability, settlement, temperature changes. Because of that crown at hinge, this is the disadvantages which we get from this three-hinged arch. So which can be disadvantage in applications requiring high rigidity. In moving to the two-hinged arch, it is greater stiffness and load carrying capacity, suitable for stable environment where settlement and temperature changes are controlled. Here it is advantage because of the absence of the crown at hinge. It is more complex because of the, in weaknesses we understand. So in strengths, it is greater stiffness and load carrying capacity, suitable for stable environments where settlement and temperature changes are controlled. So once the settlement and temperature changes are varied, the two-hinged arch is not suitable such type because it's not more flexible. It is not the settlement is also it is not allowed, and the heavy internal stresses are developed because of those scenarios. So when controlled environment for settlement as well as the temperature, such type, this is one of the recommended type of the arch. In moving to the Weaknesses, more complex analysis, less adaptability to change in support conditions, and higher internal forces required for more robust construction. These are the weaknesses. Because it is more complex, it is not, statical equilibrium equations are not enough for understanding the two-hinged arch. For getting the unknowns, statical equilibrium equations are not only enough, we require compactability equations also. This is less adaptable to changes in support conditions and higher internal forces also there. These are the some of the disadvantages in these two-hinged arches. In overall conclusion, the choice between the three-hinged and two-hinged arches depending upon the specific requirement of the project, including the expected load, environmental conditions, and the need for flexibility or rigidity. Whenever we need flexibility, we choose three-hinged arches. We required rigidity means we are choose two-hinged arches. In environmental point of view, the environmental conditions are, the temperature effects are settled, controlled environmental conditions. Two-hinged arch is adaptable. Under uncontrolled, the temperature changes may there, whatever it is there, the uncontrolled scenarios, we may choose these three-hinged arches. Like this, the variations are there. It depends upon the requirements of the projects and expected load. So each type of arch has its own advantage because this is statically determinate, statically determinate. Three-hinged arch is statically determinate. And these two-hinged arches statically indeterminate. Statically indeterminate structure. So these are the things which we are going to understand. So the overall conclusion, it depends upon the specific requirement. So what kind of internal forces are, whether it is required or not, whether it is flexibility we required or rigidity we required, it depends upon. So each, whether it is three-hinged arch or two-hinged arch, they have their own kind of advantages and best suitability to particular structural applications. So these are the conclusions. For understanding these lecture, these are the some of the references we may go through. It will give more detailing about the each type. Thank you. We will see in our next lecture.
Like, share and subscribe. Hit the bell icon for more updates.